In the following video, I will show you how to answer the Unit 3 Higher practice paper for AQA modular paper. It's a calculator paper and an hour and 30 minutes. You do have access to a formula booklet at the front with various formulae for you. I will point out which ones came from there and which ones didn't as we go through the paper. So to start with, we start off with a diagram with a map of an island showing roads adjoining 4 towns. 1 town, 2 town, 3 town, 4 town. Due north is directly up. It asks us to choose from the bearings below to complete the sentences. Salt Sea is on a bearing of from South Bay. From is the key word here. From means where we're starting from. We're starting from South Bay and we want to get to Salt Sea, it says. The bearing is always measured clockwise from the north. That is approximately 45 degrees because it's less than 90, let's say. And 45 is one of the options. So 045 completes that. Again, we're measuring from South Bay and we're trying to get to Beach Point. So from South Bay we're going to Beach Point. We're going to measure from the north clockwise until we get on that bearing. And you can see it's over 180. In fact, here would be that would be 180 plus another 90 is 270. It's over 270, so it's anything given as an option to us that's over 270. And in fact, it must be 315 given the options available to us. Now, a ring is hidden on one of the roads, so it's on one of the roads. Here are some clues to find it. The ring is on a bearing of 260 from Salt Sea, and the ring is closer to South Bay than to Beach Point. Mark with a cross the approximate position. So, I'm going to rub out what we've done previously. We're starting at Salt Sea, and we want to measure a bearing of 260. So first from Salt Sea, draw your north line. And we want to measure a bearing of 260 clockwise from that. Well, we know this here is 180. So to get to 260, we need to measure another 80 along this point here. So what you could do is get your protractor out, just line it up in the right position here. And we want to measure another 80 degrees, we said, from 0 to 80. 80 is about here. So you just take your protractor away, and now you draw a ruler. It will be on this line somewhere. Well, actually, we can just use a ruler here. It will be somewhere along this line here, we're saying. And it says to us that also the clue tells us that the ring is closer to South Bay than Beach Point. So it's closer to this than Beach Point. Well, on this road here, it's certainly close to Beach Point, so no good. This road here is closer to Beach Point, so no good. So it must be this original road here where the ring is. Okay, question 2. Boxes are packed into crates. The crate measures 210 by 120 by 100, and each box measures 8.4 by 6 by 4. So the width of the whole huge crate is 210 across, 120 back, and let's say 100 high. And each box measures 8.4 across, let's say 6 back, and let's say 4 high in the exact same way. And we want to work out how many boxes fit in the crate to start with. So, how many boxes on top of each other are we going to get? Well, we're going to get 200 divided by 8.4. Sorry. The first thing we want to work out is how many boxes we get across. So we're going to take the 210 divided by 8.4. So 210 divided by 8.4 gives me 25. We get 25 that way. Going backwards, well, we're going to do 120 divided by 6 gives me 20 boxes going backwards, and then going up we're going to have 100 divided by the height of this, which is 4, which is 25. So the total number of boxes we're going to get is 25 along here, 20 back, and 25 high. So it's going to be 25 times 20 times 25 is the number of boxes we're going to get. So that's 12,500 boxes, 12,500 boxes. Each box costs £4 to make, so the total cost must be 4 multiplied by 12,500, and we're going to get 50,000. How much profit is made if the full crate boxes are sold? The box makes a profit of 50%, so we just have to work out the profit is 50% of the cost, so it's 50% of £50,000, which is simply £25,000. So question 3. A newspaper uses the following formula to work out the cost of an advert. The cost of an advert is 10 times the number of words used in the advert plus 20 times the area of any pictures. Work out the cost of an advert that has 20 words, so n is 20, and an area of 9 centimeters squared, so area is 9. So simply substitute n is 20 and a is 9 into this formula. The cost is 10 times 20, substitute into brackets, plus 20 times 9, which is simply 200 plus 180, which is equal to 380 pence, because the formula is in pence. So given your answer in pounds is £3.80. Okay, 3 part B, it says work out the cost of this advert here. So we need to work out n, the number of words. So n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24. N, the number of words, is 24. And the area of the picture. Now, my computer hasn't measured this to scale, but if you were to measure how wide it was by how high it was and times those two things together, you should get an area of approximately 16. So you should get an area of approximately 16 centimeters squared. So the cost is therefore given by the formula 10 times 24 plus 20 times 16, and you work that out, you get 560 pence, which is £5.60. Again, just to reiterate, I couldn't work this out because the scale's different on the computer, but you would measure across in centimetres, high in centimetres, multiply the two to work out the area of the picture, and you get for that about 16 centimetres squared. The signs are put up to warn drivers of the 30-mile-an-hour speed limit. The home over times cars over 200 metres, and these are the times the cars he timed took. Well, the first thing to do is really 30 miles per hour is 13.3 metres per second, which means using speed equals distance over time. If we want to work out the time a car travelling exactly on the speed limit should take to travel the distance of 200 metres, time would be distance over speed, which would be 200 divided by 13.3. And we would get approximately, for that, 15 seconds. So 15 seconds is what a car travelling exactly at the right speed would take. Now, any car travelling less than or equal to that is probably over the speed limit, So the number of cars over the speed limit is 2 plus 3 plus 4. So 2 plus 3 plus 4 is 9. 9 out of a total of, add 10 and add 6, 9 out of a total of 25 has this proportion increased? Well, making out of 100 times top and bottom by 4, and you get 36 out of 100. Okay, so previously 46% were speeding, and now 36% are speeding. So has it decreased? Yes, decrease. Question 5. The diagram shows two shapes B and C. Describe fully the single transformation which takes B to C. Now, how would I get from B to C? It's not a translation because there's some sort of twist involved. It's not an enlargement because the shapes that look the same size. It's either a rotation or a reflection. Now, it's not a reflection because I can think of no mirror. If that was the mirror line, these are not reflections of each other. So it's not a reflection either. So it must be a rotation. So to get 1 out of the 3 marks, state rotation. It's clearly by 90 degrees, because if I move that 90 degrees that way, I get to there. So it's by 90 degrees. The next point is to think to ourselves, where is the center of enlargement? Now, to get the center of enlargement, really what you need to do is have a tracing paper over the shape B and hold your pencil down at various points and see which one works for this rotation. It works that if you hold your pencil down at 4, 3 and rotate that shape, that would be the center of enlargement. So the center of enlargement for the 3rd mark, the center of enlargement is the point 4, 3. Okay, question 6. The diagram shows a cylinder. The diameter of the base is 14 centimeters. So the diameter of the base is 14. So in particular, the radius must be 7. The height is 12. Now, work out the volume of the cylinder. We know from the formula booklet that the volume of a prism, it tells us this in the formula booklet, even though that's strictly not a prism. It tells us that the volume of this is the area of the base times the depth. So here we could work out the area of the circle and times it by the height. So to start with, let's work out the area of the base circle. The area of a circle is pi r squared. So pi times r squared. R is 7, so pi times 7 squared. I'm just going to leave that as 49 pi for now, and at the end I will tidy things up and make them accurate. And then times it by the height, so the volume must be 49 pi times 12, and when you do that, you get 1,847 centimeters cubed. Now it says choose a suitable degree of accuracy. Everything was given to us to 2 significant figures. So we should give the answer back in 2 significant figures. The second significant figure is hundreds. So the nearest, is hundreds. So the nearest hundred to this is 1800. So I would give my answer as 1800 centimeters cubed, or 1800 centimeters cubed. Okay, question 7. Here is a formula for converting from Fahrenheit to centigrade. Okay, centigrade is given by this formula. You are given that x Fahrenheit is the same as x centigrade. Work out the value of x. So if I put x in here, you are given that x Fahrenheit is the same as x centigrade. Okay, so I have to work out the value of x. So substituting x in, we have x is equal to 5/9 x minus 32. Now the aim of the game is to solve for this and find x. So multiply both sides by 9, you get 9x is equal to 5x minus 32. Expand this bracket, 9x is equal to 5x minus 160. And then what we need to do is we should subtract 5x from both sides. So we would get 4x is equal to minus 160. Then divide both sides by 4, and I would get x is equal to minus 40. So the answer is x is minus 40, and the unit is either Fahrenheit or Celsius. The diagram shows a shape made from 4 congruent right-angled triangles. Congruent means the same. Each of these triangles is exactly the same. Work out the area of the shape. Now, if each of these is the same and that side is 15, that tells you that that side there is obviously 15 as well. Now, we've got a right angled triangle here, width 6, hypotenuse 15. If we want to work out the height of this, we could do that using Pythagoras and say that this height squared must be the hypotenuse squared subtract the base squared, so the height squared must be 189, so the height must be the square root of that, which is about 13.74. So what is the area of one triangle? The area of one triangle, let's say that triangle there, well, it's half the base is 6, times the height, which we now know is 13.74. So it's half, the base is 6, times 13.74, and you get 41.2. But each of these triangles is the same, and we've got 4 of them, so total area must be 4 times 41.2, and you get the answer 165. You get the answer 165 centimeters squared. Question 9. The diagram shows a quadrilateral, a four-sided shape. Prove that AB is parallel to DC. Okay, well, we know that the angles inside a quadrilateral add to 360. So 3x plus x plus 4x plus 2x must add up to 360. How many x's do we have? 3 and 1 is 4, add 4 is 8, add 2 is 10 x's are 360. So x in particular must be 360 divided by 10 is 36. So now we can go in and write these angles. This angle here must be 72. This angle here must be 3 times 36, which is 108. This angle here must be 36, and this angle here must be 4 times 36, which is equal to 144. Now, I'm just going to draw a quick line in here. If I extended, I want to put DC and extended AB like that. Because x is 36, this little angle here must be 180 minus 36, which is 144. And similarly, because this angle here is 72, this angle here must, because this angle is 108, this angle must be 72, and that one was 72. So because these angles are alternate to each other, AB must be parallel to DC. So you can say they're parallel as angles are alternate. Question 10a. Complete the table of values for the following function here. All we've got to do is substitute x's in and get y's out. So, when x is minus 1, what's y? Y is minus 1 cubed minus 2 times minus 1 plus 3. Minus 1 times minus 1 is 1, times another minus 1 is minus 1. Minus 2 times minus 1 is plus 2, and we've still got our plus 3, so this gives us an answer of 4, so 4 goes here. If we put x to be 1 in, we would get y is 1 cubed minus 2 times 1 plus 3. 1 cubed is 1, minus 2 times 1 is minus 2, plus 3, and 1 minus 2 is minus 1, plus 3 is 2. So we would get 2 in there. B simply asks us to complete the graph. So all we've got to do is plot the x coordinates against the y coordinates. So minus 2 goes with minus 1 here. minus 1 goes with 4, so minus 1 goes with 4. 0 goes with 3, 0 goes with 3, 1 goes with 2, and 2 goes with 7. So 1 goes with 2, and 2 goes up here with 7. So drawing the line in between there, it ends up looking something like this. And it asks you to write down the solutions when x cubed minus 2x plus 3 is 0. Where does this curve equal 0 have a y value of 0? Well, hopefully you can see there, and the answer is approximately, you get something like minus 1.8, minus 1.8 or minus 1.9 reading off the graph there. It's not as accurate on my sketch on the computer, but you should find it easier with a bigger graph. A circle theorem question. It asks us to work out the value of W. Now, a circle theorem, you should remember, here's an arc. The angle subtended at the circumference from an arc is half the angle subtended at the centre from the same arc. So, for example, in the picture I've just drawn, this here would have to be half of that, which would be 42. Now, although this has been drawn quite strangely, just imagine here, W is actually an angle subtended from the same arc as the angle 84 subtended at the middle. So W must be half of 84, so in particular W must be 42 degrees. 11b, the diagram shows a circle centre O, AT and BT are tangents to the circle. Now this here, OA is a radius because it's from the centre to the circumference, and OB is a radius. Now you should know, one of your circle theorems is that a tangent and a radius to a circle meet at 90 degrees. They always form a 90-degree angle. So therefore x plus the 32 must add up to 90. So x must be 90 subtract 32, which is equal to 58 degrees. Okay, another angle you should be familiar with is tangents meeting a circle from the same point are the same distance. So that distance and that distance are equal. So if we were trying to work out y here, we know we've got two identical triangles here. And we're trying to work out this angle here, this y angle here. Now, we've got this angle x is 58. We've got this is 32. We know that's 90. So we know that this x angle in here is 58 degrees. Okay. Now, by exactly, we also know that a tangent coming from the same point touching a circle must be the same distance here. So this triangle here is an isosceles triangle, so this angle here must also be 58 degrees. So y must be 180, subtract 58, subtract 58. And we get for ourselves 64 degrees. So 64 degrees. Okay, question 12. ABC and XYZ are similar triangles. That means that there is a scale factor, one is an enlargement of the other essentially, or that there's a scale factor relating their lengths together. Work out the length XZ. So you want to work out this length here, this unknown length here. Let's call it X for now. XZ. Well, the ratio between the sides must be the same. So if I work out the ratio, this divided by this, 12 divided by 2.4, tells me that the scale factor between the lengths is 5. So that means any length here, if I times it by 5, I get that length. Any length here times by 5, get that length. Going backwards, if I've got a length here, if I divide by 5, I get the length in the smaller triangle. So if I want this length here, I do 18 divided by 5, and I get myself 3.6. So x is 3.6 centimetres. Question 13. Solve the quadratic equation. It's quadratic because it's got an x squared, it's got an equals, and it's already equal to 0. Give your answers to 2 decimal places. That suggests to you that factorising will be too difficult. Use the formula. Okay, the quadratic formula is given to you in the formula booklet. It's x is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. A is the number in front of x squared, a is 1, b is the number in front of x, b is 5, and c is the number term, which is minus 3. I always suggest, rather than typing this straight into a calculator, you work out b squared minus 4ac first. This is known as the discriminant. Work this out, so 5 squared minus 4 times 1 times c, which is minus 3. 5 squared is 25. 4 times 1 is 4, times minus 3 is minus 12, minus 12 becomes a plus 12, so b squared minus 4ac is 37. So now, just substituting in straight into the formula, we can get our x. On the one hand, x is minus b, so minus 5 plus the square root of 37, this thing, over 2a, which is 2 times 1 is 2, or x is minus 5 minus the square root of 37, all divided by 2. Then you can work those out on your calculator to get you what the answer is. So on the one hand, you get x is 0.54 to 2 decimal places. And on the other hand, you get minus 5.54 for the other one. Okay, the diagram shows a triangle ABC. AB is 5 centimeters, BC is 8 centimeters, and the angle at A is 55 degrees. Show that the triangle has an obtuse angle. Obtuse angle means bigger than 90. It looks to me like this one is going to be the one that it looks like it's obtuse. So we use the sine rule. The sine rule is given to us in our formula booklet. It's given as follows. The side over the sine of the angle opposite that side is equal to a different side divided by the sine of the angle opposite that side is equal to the last side divided by the sine of that angle opposite the side. So we can use the sine rule here. Let's choose, and also this is how it's given in our formula booklet. We should invert it when we're trying to find an angle. And inverted means you just flip everything over and the formula still works. Okay, so sine of an angle, sine of 55 divided by the side opposite must be sine of that angle, sine at B, divided by that side AC, must be the sine of C, this angle, divided by 5. Now, let's try and work out angle C. We know, forgetting about this middle one for now, that sine of 55 over 8 must equal the sine of this angle here, C, over 5. So rearranging, times in both sides by 5, 5 sine 55 over 8 must be sine of C. And that gives us that sine of C, working this whole thing out here, is about 0.5119. So C, the angle at C, is the inverse sine of this. Typing that in on your calculator, and you get about 30.8 degrees. So C is 30.8 degrees. How do you find the angle at B? Well, you do 180, subtract 55, subtract 30.8, and you get 94.2. So you get 94.2. and 94.2 degrees is obtuse. Okay, the diagram shows the major sector of a circle with radius 8. That means the radius from the centre is 8 centimetres. Work out the perimeter of the sector. Let's just get in our heads what we're trying to do here. The perimeter of the sector is this curved distance here, and then you must not forget to add in 2 lots of your radius. Okay, so what's the total distance around the outside of a whole circle, or it's called the circumference? It's given by the formula 2 pi r, where r is the radius. Now, how much of a circle do we have here? We've got, out of 360 degrees in a whole circle, we've got 280 out of 360 degrees. That's how much of a fraction of a whole circle we've got. So, to work out the fraction of the distance, we multiply this fraction by 2 times pi times the radius is 8. And we work this out. And you get approximately 39. Get 39.1, and then you have to add in 2 lots of the 8. So the total perimeter must be 8 plus 8 plus 39.1, and you get approximately 55. You get approximately 55 centimetres. Okay, the graph of the curve y equals a plus bx passes through the points x is 7, y is so x is 1, y is 7, and x is 2, y is 13. A is bigger than 0, b is bigger than 0. Work out a and b. So let's just substitute numbers into this equation and see what we get. X is 1, y is 7. So we get 7 must be a plus b to the 1. And b to the 1 is just b. So 7 equals a plus b. Sticking in 2 and 13, we would get 13 equals a plus b to the 2, so we would get 18 equals a plus b squared. We've got 2 equations here, 1 and 2. If we took equation 2 and subtracted equation 1, it would eliminate the a's. I would get 13 take away 7, which is 6, a take away is nothing, and b squared take away b. Now there's a quadratic in terms of b. To solve it, make it equal 0. So subtract 6 from both sides. I'll do this working here. We'll start 6 equals b squared minus b. So the next line will be 0 is b squared minus b minus 6. Now we try and factorize. Well, this factorizes 2 numbers that times to minus 6 and add to minus 2. They're b minus 3, b plus 2. And making both brackets equal to 0, I get b is 3 and b is minus 2. The question tells us b has to be bigger than 0, so b is 3 is one answer. Substituting 3 back into that equation here, a must be 4. And question 17, the diagram shows 2 triangles ABD and BCD. Work out the size of angle BCD. So we want to work out BCD, this angle here. Okay, well, in order to be able to do that, we would need ourselves this side here, this side BD, because we don't know any of the angles inside this triangle. So let's try and work out this side here. We can use the cosine rule for that, and that says that the side you're trying to find squared is the other 2 sides, the sum of the squares of the other 2 sides, subtract 2 lots of that side times cos of the angle between the 2 sides, cos of 73. So BD squared, well, let's just work it out. So working it out, you get BD squared to be approximately 102.89. So taking the square root to get BD, you get about 10.14. So this side here is 10.14. Now, if we want to work out this angle here, we can use the cosine rule on a second application. The cosine rule says that cos of the angle you're looking for is the two sides, is the square of the two sides around the angle, b squared plus c squared, take away the square of the side opposite the angle, a squared, all over 2bc. So cos of this angle c, cos of this angle we're looking for c, must be 7 squared plus 5 squared minus 10.14 squared, all divided by 2 times 7 times 5. So working that out, we get that cos c is equal to minus 0.41. So I'm just going to take this working up here. Cos c is minus 0.41. So taking the inverse cos to the minus 1 of minus 0.41, you get the c must be 114.4 degrees. So the angle at c must be 114.4 degrees. Thank you very much for listening to this video. I hope you found it useful in your revision for Unit 3.